2-hour drive.
And I'm like, this is when I'm still at home, so I don't know what's going on. I was like, okay, and I said, haha, thanks girl, it looks
She
good.
said, how are we gonna just leave one there all alone? And I said, I mean, we don't have
So
to.
I told Tony that, and she's like, I have that stuff. Stephanie is so organized.
We were having a conversation, we were all having a conversation about something. She probably got on some text message.
She was perfect this side,
Oh.
the birds and man just to have to go get him outside. Was that not like, it was so unique, and she's like crossing out things, like disregard this, like. Just to have to scrap beside.
I feel like
and
yeah.
All right, let's get started.
I did the results in my own.
Tony, you did something with your hair.
And if my answer to that, they don't call my name.
Oh, we gotta bring it up, right?
Okay, let's see, weather. Our test is this Wednesday. If you don't feel safe coming for the test Wednesday, I mean, if we're open. I've never noticed a close for cold. I don't remember hearing that. But anyways, it's your option if on Wednesday. If you don't take the test on Wednesday, you just will retake it. We'll just make a time for you to retake it. So don't risk your lives to be here. Okay? Let's see. Any questions about the test?
Do we have to take it?
No, you don't have to take it.
But we won't go on. And like,
I feel like we've literally never had to take a test in ECE classes ever. So this is like,
shocker.
you know, you're the only one. Makes us take that.
Well, I think there should be some rigor. Actually, the reason why I have you taking the test, if I haven't said this before, is because I want you to really study this material, because it's probably the last time you'll really look at it. That's really why. It's really not to get the grade. Yes?
So I just want to like clarify.
No, I'm sorry.
So we've done the fundamental concepts, the math practices, time, and month. And that's what we're gonna have, right?
Let's see, is there anything else besides those? I think we covered about everything.
I just wanted to clarify like the things that we have gone over in these past years, to make sure I didn't miss it.
And maybe,
Bloom's. Remember Bloom's taxonomy?
Yeah.
Math practices. I think you covered everything.
Okay. So just those four like overarching things and then study.
I probably just put it in my room, not as much as I was taught.
Okay. Just want to make sure we're getting everything.
That's good.
But after the first couple of nights, should be okay.
Any other questions? Okay, have you talked about patterns before, like AD? What course did you talk at? What are you talking about? Oh, 111, 112, I talked about AD patterns and all that? Okay. I wasn't sure about it, I just do that.
Like he's saying A, B patterns, like A, B.
Okay, so click-clack moves about, there's patterns, have you seen click-clack move before? Okay.
Shannon's like facial lit
Okay.
It's her favorite book ever.
It is? Okay, has everybody seen this book? Anybody not seen it? All right.
I know, yeah, we've seen it.
Probably one that you haven't seen is this pattern fish.
I like it. Something different.
Okay. So here again, patterns are important for us here in math because obviously, I mean, you see it right up here, patterns. Okay, and that's what math basically is. It's a bunch of patterns. We talk about the structure within math. Okay, how it has reason, has sense to it, has patterns in it. Okay, so here's one pattern fish. yellow, black, fish swims in the ocean. It has stripes upon its back. Yellow, black, yellow, and it's waiting for the students to say
Brown. Oh,
black.
I missed that, sorry.
All right, if you look here too, they have a lot of patterns in here that are this is AB pattern. Can you find a lot of patterns, AB patterns in there?
The border.
The border,
Snail, striped dot,
okay.
the seaweed.
The seaweed,
The bubbles.
and
Those
this
are the
one
dots,
too.
right?
And what?
Or you said the dots, right, the bubbles?
Yeah, well,
No,
no,
the
I
bubbles.
said there.
No, she didn't say the bubbles, she said the stripe.
Well, the bubbles like big little, that's ABA.
Yep,
Is-
AB.
And tail, not like the fin.
His tail, okay.
The entire thing.
So now you can start talking about, that. Matter of fact, even the little seaweed here, little dash dot, dash dot. Okay. Stripe dot dot, stripe dot dot. From a dark and rocky nook, an eel slips out to take a look. Stripe dot dot, stripe dot dot, stripe dot.
Dot.
Let's see, she right. Oh, come on. Okay, and again, you can see the patterns. Okay, so that's basically what this book's all about. So when you talk about patterns, it's a very nice book. Of course, Quick Back Blue is a very nice one too. Let's hand these around. Make sure you write down the authors. Oh, the games are due Wednesday, March 13th. Okay, Wednesday, March 13th. You can turn them in prior to that if you'd like. Okay, now we're going to talk about matching, discriminating, bless you, discriminating and categories, classification.
What's on thrift book?
There's just two. Can you get like a gift board?
Okay. Yeah. Let's see, matching and discriminating. Matching refers to how two things are similar. So development of preschoolers and kindergartners. Nice thing is to get a bunch of here. I mean, any buttons, you can just collect buttons. Okay? So if you're preschooling, you have to be careful about them putting things in their mouth and choking. But they could look at this and they could say, okay, this and this are red and this is red. Of course, I'm matching right now. Okay? Matching how two things are alike. Discriminating is how two things are different. Okay, so a little bit of difference now. So if the child is just pulling things out that are alike, like they pull out this one and this one, not that one, this one, they're just looking for things that look like this, a button with 4 holes in it. Okay, that's matching. They're just focused on that. They're just looking and matching. Okay, discriminating would be seeing how things are different. So maybe I have, this is different than this, so I start making another category here. These are, actually they're all pretty much the same shade, but these are a different shade, okay? So I'm discriminating, this is different than this. Okay? And then classification is using both of those skills. So if you have a group of buttons like this here, and you sort them or group them, you're classifying them. So sorting, grouping, classification. Okay, you're developing a system. So for example, looking at all these buttons right in here, might say, all right, we need to put these in here too. So I have all these buttons that have 4 holes in them. So I might say, okay, there's 4 holes. I have all the buttons that have 4 holes. And now I'm going to take the larger buttons that have 4 holes and put them over here, and the smaller buttons over there. See, I'm starting to classify them. And then I could say, oh, well, these are the blue smaller buttons. These are the orange smaller buttons. And these 2 here, and this goes here, and these go like this. Okay. All right, so that's a classification scheme. All right. Students begin with matching. What do you think they match first on?
Color?
Color. Always color. All right, so if you're in preschool, that's what they're going to match on. Discriminate, they're just taking things and putting them apart based on some attribute, some characteristic. And then classifications using both of those, matching and discriminating. Welcome. Make it some kind of structure. Again, math is all about patterns and structure. Okay, these are called Woozle cards, if you want to get them out. So you could use these with a preschool, kindergarten class, first grade class even, second grade class even. Okay, so these Woozle cards, they sort them in some fashion. How do you sort them? Sort them into 2 or 3 groups. Okay, you sort them by color. By color. You're going by how many dots. All right. So if you're first pulling out like all the same color, you were matching. If you started to separate the colors, you're discriminating. Okay? And now I want you to look at what you've sorted them into, the groups you've sorted them into, and within those groups, can you sort them into separate groups? Okay, and do all your groups. So you can have 2 or 3 groups, and now you're sorting and matching within those 2 or 3 groups. This is classifying. Okay, so you see some kind of classification structure. Maybe you have the pink, yellow, and the purple, and then within the pink you have some other set of groups, and the yellow some other set of groups. In your case, Lauren, you have the dots. So between the 2 dots, then you separate them into colors. Okay, so 1 dot yellow, 1 dot purple, and so on. Okay, now within those groups that you sort them into, you sort them into another group or groups. Okay, so your classification scheme is getting even more and more complex. And then in those groups, see if you can sort them further. Okay. Now this could be some kind of, it's really an activity, but it would count for a game if you did similar to what I did with these cards. Okay? Those are called Woozle cards. Okay, now take these cards, you can put those in the bag. Take these cards and shuffle them.
Are we done with
Yeah.
this one?
Yeah, we're done with Woozle cards. We get out once a semester. All right, shuffle these cards here. Okay, once you have them shuffled, the reason I have you shuffle is because last year's class might have put them in a certain order. I want you to create a classification scheme. This should be a bunch of movies that you should be familiar with. Maybe when you were, I don't know, maybe you were in middle school or high school, you would have seen a lot of these movies. So go ahead and make a classification scheme. This is really more, actually, this you could use with a third grade class for sure. So think about taking, we're always trying to reach the students with their own personal interests. Now usually the age group you're in, they're interested in everything. That's the real nice thing about kindergarten through third grade. They're really interested in a lot of stuff. Like the Woozle cards, you bring them out, they're interested in them. When you get in the fourth and fifth, that's when they start to become more particular. So if you're going to do something like this in the fourth or fifth grade class, you might choose the movies that they're familiar with. Okay? Okay, how are you guys, what's your classification scheme that you chose? Okay, so you got superhero, animation, fantasy. Okay. Okay, now that's interesting because that'll happen too. What Lauren did, where she's at right now, that will happen in a classroom. You'll see that with students where they will have an other group. So if you were first sorting these movies and you said, I don't know what to do with these here, they're an other group. And so a lot of students will have that too. And the bigger that other group is, it probably means that students need more time classifying and sorting. Okay? So you'd be looking in your classroom and your kindergartners, and one has a big other group, in other words, only have really two things, and one has a very small group, that's telling you a little bit about their abilities to sort and group, okay? And that they just need more time doing that. Any other schemes?
We did the guns.
Guns?
I'm literally thinking about doing this.
Yeah.
Okay.
I mean, this is hard for us. I don't, you guys all get the same, yeah, we get the same ones. I'm like, I don't know, because it's like Guardians of the Galaxy has guns, and Transformers have, like, right on the front they have guns.
Okay.
So.
Oh, that's fine. So
American
guns
Sniper.
without guns? Okay. Did you sort beyond that?
We did like superheroes, animals.
Okay. Jan, did you?
Well, I was gonna say, like, they're kind of all have one theme, which would be an action type movie.
Oh, they're all action?
They're all
Okay.
action. Even the kids' movies, actually. Even though Lego movie, I'm pretty sure it's action in there.
So, I mean, that's interesting because you could then put, the title could be action movies, and then the subgroups are, types of action movies. Okay, like superhero.
Because then you can do that, yeah,
fantasy.
superhero,
Children.
comedy, one could be other comedy.
Yeah, I think like starting with like possibly guns and then no guns, and then going
Oh.
from there is like.
Okay.
I mean, we'll just sort that. Yeah, I mean, you're not really.
What's that, Charles?
We'll probably
Yeah.
make that a category,
Yeah.
but. No.
A lot of your students, how do you think a lot of your students might sort them? Well, maybe two categories they begin with. What?
Cartoons, no cartoons? Ones I
It
like.
could be, I mean, all these are, I just have one in mind, but I don't have the right one.
Movies I like and movies I
Movies I like and movies I dislike.
Or we do that, still be like, oh my gosh.
That's what you did?
Oh, yeah,
Yeah.
why didn't we do it like that?
Okay, that's all we're gonna use that for. I'm just trying to give you something a little bit different.
We got really technical.
Oh, got technical.
Oh, we did.
Oh,
You guys are like
What was-
hyper-analyzing. After we sorted it between what we seen and what we haven't seen, then we were looking really hard and trying to figure out what to do next. And then Caitlin pulled up the Lego movie and said, well, this is animation. And then I was like, well, Melissa has some animation, but not all. So then we were like, this is 100% animation, this is partial animation.
That's good.
Am I saying it wrong?
Animation. Animation, we're like,
It's like, what?
and then, so
So
you
the
said,
teacher
wait, the next time I go self-corrected.
Correct yourself.
You self-corrected, that was great, we encouraged that.
Animation.
Animation, then she said, wait,
Now I'm not gonna be
animation.
able to say it right.
Self-correct, animation.
I said it 5 times.
But you said animation the next time, and I was just like, self-correct.
Okay, number sense and numbers. We're moving into this, and we have a video that'll show you some things with numbers and number sense. It's actually very interesting. Number sense is being able to look at a collection of items and have a pretty good idea how many are in that collection. Okay, so look at a collection like of buttons, for example, and you have a pretty good idea how much is in that. You can estimate it fairly well. And how well you estimate tells you how much number sense, how much you've been around objects and trying to figure out how many there are. Okay? And you're going to see that in this video, that the students, as they get older and they've been around numbers more, they're able to estimate it better. Like something like this here, if you asked a kindergartner how many buttons you think there are, they'd say, well, they could say that, they probably would just say, oh, 5 or 6. Okay, a first grader would say, oh, about 20. Okay, now what they're doing is kind of what you're doing, in that they're going to a number that's just way out there. They just can't fathom what that looks like. Okay, so a kindergartner, when they first learn to count, they understand what 1, 2, and 3 looks like, because they've had 1, 2, and 3 a lot. And even if they've counted to 10 or 20, they really don't know what 6 or 7 looks like, so they think, oh my gosh, there must be 6 or 7 there, because it's way out there for them. Okay, first grader, they kind of know what 6 or 7 looks like, but 20 is just way out there, just like for us. And those are some of the, they do this with adults, like every once in a while they'll have a car in the mall, I don't know if they still do this or not, they fill it with ping pong balls or something like that. And they say, you guess how many ping pong balls are in here, whoever's closest gets the car. Have you ever seen anything like that?
And no one ever wins that card.
Okay, and so what they're doing is, because the number of ping pong balls is beyond what most adults can really understand, that they're way off. They might get, one from 1,000 to one to a billion and anything in between. Okay, so that's kind of what the fun of that is. Okay, so that's what number sense is all about. Students, are there 3 purposes for number? Okay, what do we use numbers for? When you see the number 5, what are you thinking? How many? Okay, you use numbers to count. Cardinality it's called. Okay, how many is in the set? Think of a football team. How do we use numbers there? Jersey number. Identification. Yeah, we identify them. In other words, what is, I can't think of the quarterback's name now. The Browns' new quarterback, Mayfield. Baker Mayfield. What's his number? Is it 2? It's 6? Number 6. Okay, so he wasn't like the 6th player picked. Okay? He just has, so it's identifying them. So we'll just say name objects. And the third one's called ordinal. What order they came in. Okay, so there's 4 teams in the AFC North. The Browns came in 3rd. 3 indicates their position, the order. Okay? That's the way we use numbers. And the kids will get experience with these over time, but pretty much what they begin with is cardinality. Now they come to you in kindergarten, and usually the parents are given a slip, given a paper prior to kindergarten when they sign up and they register for kindergarten, and it says, please work with your child to learn these things, like colors, bless you, like colors and numbers, and counting up to 20. That's usually what they want. So usually they come to you able to count to 20. Of course, preschool, they're working on this too, but not everybody's in preschool. Okay? So when they come to you, they can go 1, 2, 3, 4, 5, 6, 7, 8, and they don't know what those numbers mean. They usually don't know what those numbers mean. They just go 1, 2, 3, 4, 5, 6, 7, 8. That's all it is. That's called rote counting. R-O-T-E.
So you're saying rote counting is just counting numbers and not putting, object to it, just knowing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
Yeah. That's what most of your kindergartners will, unless they've had a really good preschool. So a lot of parents are proud, oh, my child can count to 50 or 100, you know, they only want it up to 20 here, and they told us only up to 20, they can do up to 50, and that's good, they can count up to 50, but they don't really know usually what those numbers mean. So somebody in that group, when they're first learning their numbers, like if you ask them, you know, count these objects here, they might have a hard time, you know, what do you mean? And then you might say, you know, 1, 2, 3, and they say, okay, that thing I learned, 1, 2, 3, somehow I'm attaching it to this here. But they'll do this a lot. They'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see how they see no connection really between it. Okay, so that's rote counting. And that's where they usually begin. Now, rational counting is knowing what the numbers actually mean. number or number constancy, and one-to-one correspondence. And these kind of indicate how much experience your student has had counting and using numbers. Okay, so this is kind of like a guide in a way, depending on how well they do on these measures. If they counted a lot of objects, or if they haven't counted a lot of objects. Okay, I'm going to tell you what each one is. Wait, let you guys write the terms down. Okay, so counting all. If you began with, you're working with a child. You said how many? They 1, 2, 3. Okay, and then you said, brought another one up there. You said, now how many? They go 1, 2, 3, 4. And you bring up another one. Now how many? 1, 2, 3, 4, 5. They're counting all. They start over. Okay, that's telling you that something about them, that maybe they don't recognize that the number is staying the same that was left there, they're just adding one more, okay? Or it's just the very next number in that rote counting sequence. But something's there, it's telling you that they haven't had a lot of experience counting like this. Okay? Now counting on would be, with the child, the same task. You say count those, and they say 1, 2, 3. And you bring this one up, and they say 4. Bring this one up, you say, now how many? 5. Okay, that's counting on. That's telling you something that they've been counting a little bit more than a child we just were talking about. Okay, it doesn't mean there's any kind of learning disability or anything like that. I mean, there could be, but that isn't what we usually think of at this age. Okay? Now, counting back is supposed to be mastered in first grade. And so you begin here with, 5, and you take one away, and if they go 4, 3. So there's counting backwards. We're going to talk about that a little bit more after we see the video. Counting back, that's very difficult. It's hard for teachers to teach. And if you think about counting back, how difficult it is for a child, think about spelling university backwards. Just right now, just spell university backwards. Like get 1 or 2 letters, and then what do? You have to kind of like start from the front, or look at, or visually see the word university or something, right? You don't get very far. Like YT, then you start, and then you begin at the beginning, okay? All right, that's what it is like for students when they start counting backwards. Because they're so used to seeing things forwards, you know, in preschool and in kindergarten, that suddenly you're asking them to do something like spell university backwards. Very difficult. Okay, they don't have that sequence down yet. Conservation of number or number constancy. What that means is, if I would put these 3 items here, or I'm going to put 4 here, I say count them, and they go 1, 2, 3, 4. And if I do this, now how many? 1, 2, 3, 4. Now how many? 1, 2, 3, 4. In other words, this child doesn't recognize, doesn't have conservation of number, bless you, or number constancy. They don't recognize that the number doesn't change. Okay, so you're just moving things around. So they will look at other parameters. buttons and hand buttons. And for a child that does not have conservation of number, they will say, well, you have more hand buttons than round buttons, because they're bigger. Okay, so there's things like that. But conservation number, really the primary thing is that when you move them around, or even add one to it, they recognize that that other number stayed the same. The number stays the same, which may explain while counting all, they have to go over it again. Because if they don't have number constancy, then when you have, they count that as 3 and you put something here, you change something. It's like, oh, you change, it's like when you move things around. You change something, I gotta count them all over again. Something happened. Yes?
Is that similar to when kids, like, I've seen people with different sizes of glasses or something?
Yeah.
And then they pour the same amount of water in each glass, but one looks like it has more, even
Yeah.
though it's actually equal. Is that the same thing, just with numbers here?
Yeah, it's exactly the same thing. That I think is like volume constancy or something, I think, and that's later in that wouldn't be like I mean, you develop that, I'm not even sure exactly when, but it's beyond kindergarten, okay? Same with speed, like if your car is coming up onto another car, a child will say, in terms of velocity, they'll say they're going faster, even though you're coming right up on them. Okay, again, they just don't have that, some kind of constancy there, or something going on there. But yeah, you're right, Kayla, it's exactly the same thing. One correspondence is saying one number for one item, so 1, 2, 3, 4. Okay, as opposed to what I did before when I said 1, 2, 3, 4, 5, 6, 7, 8. This student 1, 2, 3, 4, 5, 6, 7, 8 does not have number constancy. This one would. 1, 2, 3, 4. Okay? All right, those are the terms we're going to use. I think that's all the terms that you need to see before we get into into this Kathy Richardson video. How about we start at 5 after 11? Oh, I'm sorry.
Can you tell me how you want us to write down the one-to-one correspondence as a definition? Is it just as easy as it sounds, one for one, that's what you want us to write?
Yeah, pretty much it's for every number you say, there's one item. Okay? All right, how about 5 after, oh, sorry.
If you teach one-to-one correspondence, how does that alter that, like, their perception when you get into value of like currency, like, well, here's like about money.
Yeah.
So you have one coin, but that one coin is worth like 25 pennies, or
Yeah. I mean,
is that
that,
something like?
yeah, that's something, I mean, if they have one-to-one correspondence, they're still looking at 1 dime as 10. So they aren't
Okay, so
looking
if
at.
they're seeing a value,
Yeah.
one coin equals one value.
Yeah.
So it doesn't have to equal 1 unit, it could be
Correct.
X unit.
Yeah.
Okay.
Modernize my movies.
I watched this weekend.
Oh. No one did like Emmy Award winning versus not Emmy Award, or Oscar. That's what Oscars is.
Probably don't know enough to be able to distinguish that.
I wouldn't either. Bless you.
Thank you.
I wouldn't know the Oscar ones.
Oh, yeah, sorry.
If I it's too warm back there, just you turn it off or move it.
Oh no, it's cozy. It was so cold outside. It was.
I know, it was. And this Wednesday.
Awful. I will be shocked if we have classes Wednesday.
Honestly, that's how I, cause like I walk so far, cause I go from, like you were
Yeah,
present, I walk
right.
from here
Just
all
from
the
my
way down to
apartment.
Beach Hall. And I'm like, on Wednesday, I'm nervous. I don't have a lot of like warm weather stuff,
Yeah.
and it's like warm like clothes, so I don't know. I don't usually like,
Oh, that's, I mean, if you can't, that's fine.
well,
You need to have those vacuum tubes, you know, you just get in.
or like an underground tunnel.
Yeah. Simple.
Yeah, my sister got
It's what?
my sister got that for her birthday.
Well, what's it supposed to be? Something satanic?
Something satanic.
Oh,
It's the
satanic.
hand, it's the hand of Fatima. It's supposed to like, it's a over like, relic, and it's Hindu. It's supposed to protect you.
Well, it let me through.
There you go. That's all.
Yes. I
All
know.
right, let's hear this.
It's either gonna be Alfie or Theo. Won't be in the
Okay, let's take a look at how children think, very, very young children, kindergarten, first grade, when it comes to number sense, okay? Now with this, Kathy Richardson, she is doing this assessment, and in an assessment, you don't really teach, okay? So as you're watching her, don't expect her to say, well, here's the answer or anything like that. She's just assessing them, seeing what they know about number, okay? The more experienced they are with working with numbers, working with objects and counting, the better they do on these tasks.
Most children come to school using words to count. We often assume that these words have meaning for them. However, being able to count by rote is not the same as understanding number quantities and relationships. In this video, we'll examine the levels of understanding that are a natural part of the development of number sense in young children. We will look at questions that will help us get information about our children's developing sense of estimating, counting, seeing relationships, and comparing numbers. In this first assessment, the children are presented with a pile of 20 to 25 counters. I ask the children to first estimate and then count. I can get more information quickly about the child's level of understanding of number if I start with a large group of objects and then make it smaller if necessary. As I listen to children estimate, I'm getting an idea of what they think a large number is. If you had to make a guess how many cubes there are, what would you say? Just make a guess.
6.
What would you guess?
8.
If you had to make a guess about how many cubes there are there, what would you say?
7.
No. As children become more experienced with number, 20 becomes a big number to them. Cody, if you had to make a guess about how many cubes there were in that pile of cubes, what would you say?
20.
You just look at those and make a guess about how many you think there are.
20.
Terry, could you guess how many yellow cubes are in that pile for me? Just a quick guess.
20 of them.
The following questions are in my mind as I watch the children count. How high do they count by rote? Do they count each object once and only once? Do they have a way of keeping track of what they counted? And equally important, I want to know, are they confident? Are they consistent? You may wish to stop the tape after each of the following children to discuss what you observed and what questions were triggered by the children's responses. Did you check and see how many there are?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 29, 22, 23, 30, 40, 50, 34, 33, 32, 40, 43, 44, 45, 46, 47, 48.
Think about this many, how many do you think that is?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
And how many do you think this is?
1, 2, 3, 4, 5, 6, 7, 8.
Okay. And what about this many?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay. What do we see there? They're a lot of fun. Yes.
Well, you could see that he really didn't have that sense of like, he was just kind of rote counting, not really seeing a value. He was just like pointing and counting. So when he
Yeah.
had all of those, he just kept going over the same ones to go as high as he could go.
And
I
row.
felt like, yeah.
Yes.
You could tell that he was confident when he was doing it though. He didn't like go, oh, I messed up. He
Or he
just
just
kept
started
going and
Yeah.
he just kept jumping around and then he's like, it's 48. Like, at the
Yeah.
end, like that's what he came up with.
Yeah, which is really important because, you know, you talk about math anxiety, and even we all are gonna make mistakes in math, we're supposed to make mistakes in math, that he would be one that wouldn't panic. Okay? You notice, oh, yes.
He did better somewhat when the cubes were more spread out than when they were like super clumped together. He was still not correct, but he was closer like with the 7, 8, and 10 ones because
so he didn't have a system that to take them apart. But when she did it, he was able to do it a little bit better. Tony?
It seemed like he always counted the first one twice when she separated it more, so he almost had the right answer, but then he counted the first one again, and he didn't have the right answer.
Yeah, you wonder if he's trying to go around and make a perfect circle, you know, and come back to start before he ends. You know, I don't know what he's thinking, but you know, those kinds of things can interfere. Yes?
Do you think that could be like, you know, when some students forget to like jump off to the next number, like instead of counting on? I always feel like that's how his like, he was thinking, like kind of that whole, you know, use it circular process. I don't know
Yeah.
if that makes sense.
Yeah, well, didn't we have that with the pennies, when they were counting them in that vignette, where they said, I know this is 25 cents, and then they counted it.
Yeah.
They do like
It was
26, they started with
Yeah,
a
it was
quarter,
29
or something
cents,
like
and
that.
then they counted, it was 28 and they counted 29.
Yeah, yeah,
So they
something
counted
like
quarter
that.
as one of them.
Yeah. One of the things that I noticed is that he seems to have, well, doesn't have good one-to-one correspondence beyond 7 or 8, but up to 7 or 8, he seemed to have it. He never missed when he counted up to 7 or 8. And then at the last task he did, he got to 10, one-to-one correspondence. So in other words, this is working, you know, just giving him these tasks over and over again, he's starting to develop it right before our eyes. And then what he's doing, he doesn't have a system to separate those. I mean, none of us, I believe, could count them the way that they were set, you know, all bunched together. You know, all of us in this room, I put that there, that'd be kind of hard to keep them separated. Just telling us that he hasn't done a lot with them. He just needs more time with them.
We know that Josh can count by rote to 23, but he has not yet figured out that he must touch one and only one object for each number when he counts.
Jason, would you guess how many yellow cubes you think are in that pile? Well, okay, well, you check and see how many there really are. Let's see, would you count this pile now, and would you count out loud so I can hear you? Okay. Okay, that's 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What about this many? 7. Okay, let's check. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13. Okay, what about this many? 8. You know there's 8, don't you? You want to show me? 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to try it one more time? Let's try one more time. 1, 2, 3, 4, 5, 6, 7, 8. What do you think, 8 or 9? 8. What would happen if you counted one more time? 1, 2, 3, 4, 5, 6, 7, 8.
Comments?
He was like, if you ask me to count this one more time, I'll count it.
He goes into like a baby voice that third time.
Yeah.
Yes?
He had a lot better one-to-one correspondence, like he would double count, but you saw like for each number he was counting, he was putting it in one block. Whereas the
Yeah, and he was able to, so he does have the one-to-one correspondence. Still can't, yeah, then the first child, still can't push them apart, doesn't have any system. Yes?
We didn't know like what actually happened, but it seemed like he was, when she originally asked, it seemed like he was trying to count it in his head. And then, when he counted 9, he questioned it because he really thought it was gonna be 8.
Yeah, because he studied those blocks
Yeah.
when he gave the estimate.
Yeah.
Yeah, so he was surprised.
In
he
your head,
got
right?
it.
Yeah.
And then when you counted it, no.
Yeah. Yeah.
That was kind of confusing to me. I don't know how to phrase the question, but like, why did was he able to do that? Because he was confident that they were 8. But I feel like usually the students count better with that, like, physically count, that's how they kind of start, it's like, okay, 1, 2, 3, 4. But she looked at it, saw 8, so I kind of like, I don't know, how did he do that? That's not typical.
Yeah, I'm not sure because, his hand was coming in between him and the view of the blocks he was counting. And so I don't know if that kind of broke his, like, starting point or something like that, and then he just, came back to it. Yeah, I'm not really sure what's going on there. But, I mean, you can see that he still needs more time, but that he's doing, he must have played with the blocks or counted them more than the first child.
Jason is inconsistent when he counts and is bothered by that. However, he has not yet found a way to keep track of what he has counted.
Can you find out how many there are? Okay. 1, 2, 3, 4, 5.
Amanda keeps track of what she has counted by moving each object one at a time.
1, 2, 3.
After the children have counted, I first add one counter at a time and then take away one counter at a time while asking the question, how many now?
Now how many think there are? 24. Now how many? 25. Now how many? 26. Now how many? 25. Now how many? 24. Now how many? 26. 22. 21. 30. 40. 18, 19.
How many now?
20.
How many now?
21.
How many now?
22.
Now how many?
21. 20. 30. 40.
What is going on here?
What do you notice there?
Yeah. Is this in 1984?
And then 19, they say 30, and then they say 40.
Charlie? Is that more?
No.
Oh, I thought.
We were talking
about
the
the
same
clock.
thing.
That's hilarious. The clock sheet.
But, they got to like 20 with 30.
Yeah,
That was really interesting.
yeah, they both went from
They
coming
got it
backwards.
until they went to 20. They
Yeah.
were able to get it to a certain degree.
And could you tell by their actions, the way they were saying it, they were not confident in those answers? That as soon as they hit those, they were
You could
30,
like mentally counting.
40, you could just see that they had lost confidence. They knew something was wrong, but they didn't know what to do. Any idea why that would be a particular, why they both would kind of have trouble in that area?
Like why they went to 30.
Yeah, why they would choose to go to 30 rather than go to 19 or 18?
Well, all I can think of is if she was at like, what was it, 24, 25 or something like that, and she took one away, all they have to do is change the 5 to a 4 and keep the 20, but once they get to 20, they're totally changing, there's no 2 there anymore, now it's a 1, so maybe that's where they get mixed up, and then they say 30, but she never told them they were wrong, so then they're like, 40, like, it was all, like, they weren't confident, but they were confident enough to keep going because she didn't tell them that they were wrong.
Yeah, and they probably were weighing in their mind, because you can see that they know it's wrong, but she's letting them go, which means, oh, maybe I'm wrong, you know, and maybe I'm continuing to count correct. In other words, I'm wrong in my evaluation that something's wrong here. Okay? Yes? Okay, well, I think, Tony, you're hitting one of the big things in that they've got to change that first number, or the tens place. We got to change the 2 to the 1. Okay, so that's one thing. What else do they have to change? A 0 to a 9. Now think about it. If they're thinking 23, they're thinking, what comes before 3? 22, 21, 20. What comes before 0? And go all the way back up to 9. So two things are happening right here. Okay, both digits are changing in a very strange way. Yes?
I think going off of that is like 0 is all the way on this end of the spectrum, 9's all the way on this end of the spectrum. How can they be close to each other again when you look at it?
Yeah, how can you jump from 0 to, I can understand jumping from 3 to 2 or 2 to 1,
Yeah.
1 to 0, but 0 to 9, that's an odd jump.
So
Yes.
do you think that instead they're going, okay, so now I'm at 20, and I've been changing one number, so I'm just gonna keep, I know I can't go past 0, so we're just gonna jump 30.
Yeah, it sounds like they're like they've been skip counting, you know, like 2s, 5s, and 10s. And so the only thing they know after 20 is either 21 in their counting sequence, or 22, which they don't, or 30, or 40, or 50. Now, they kind of chose one sequence. They're looking for an answer somewhere. Okay, they can't figure this out, but they know that they're choosing something that doesn't make a lot of sense. Okay, the other thing you have to consider too, the girl did not get from 21 to 20. Okay, she got at 21. I believe that she went to 30, then 40, and the boy did get to 20. Okay, now look at those numbers here, going from 1 to 0. When you ask a child in kindergarten to start counting, where do they begin? They begin at 1, right? That's the first number. Okay, so for a lot of them, 0 doesn't exist, or it's an oddball thing. And even in the development of math, 0 came much later, because when you think about it, if you're counting things, why do you need something for 0? For nothing. Okay, so the 0 came well after it. And the last thing to consider, and this is a big one, it's unique to the English language, is that, let me just kind of put these up here, see if you can figure out. Okay, what do you notice that these three have in common that the top one doesn't? I'm sorry, yes?
They keep the same, like, 20. So you don't go 10, and then there's no, like, 10, 1. Like, you're like a 1, 2, or something like that. It
Yeah.
doesn't follow that, so those numbers in the beginning are inconsistent with the 21, 2, 30, 31, 32.
Okay, Caleb?
It might be the same thing she's saying, but like when you're in the teens, you are saying teen, whereas the following numbers, you're saying the value of the like the 3, the 2, the 1, whereas you're saying 13, so it's a completely different name to kids.
Yeah, so you're both hitting onto different aspects of the same thing. Basically, there is a pattern here: 43, 33, 23, 53, 63. Okay, you keep saying the tens number first. When you hit up here, it's not 10, 3, 10, 2. Matter of fact, these are unique words. You know, 13, and 12, actually, there you have 12 and 11. So you have 19, 18, there is a pattern there for 19 all the way to 13, and then it stops there too, which is another thing that students have to learn. 12, which has nothing to do with 1, 2, or 10, 2, or even 12 teen, or something like that. Okay? So there's a lot going on with the teens. The teens are very difficult for students to learn. Okay? For all the reasons we just said. So they have an awful lot going on just to get from 20 to 19, because now if they are in that mode of, 33 or 23, and if they see 19 in their head, they might still be looking for what comes before 20. The twos, like maybe before the threes are the twos, before the twos are the ones, but they're looking for a number that says 1 something. I don't know, something like that. It's very complicated. Does that make sense, sort of?
It may have been surprising to see how easily children slip into a rote counting sequence that doesn't make sense. This is another example of how number words have little meaning to children until they have had many, many experiences.
Now, how many do you think there are?
25, 24, 23, 22, 21.
Check.
We could see that Linda understands that there is one less in the pile when an object is removed, but does not know the backwards counting sequence for numbers less than 20.
23,
Now how many?
21,
Now how many?
20,
Now how many?
19. Or count backwards on.
In this next assessment, the children are presented with trains of various lengths and asked to find out how many in each train. I want to find out if they see any relationships between the trains. Can they use the information about one train to figure out what they don't know? Or do they view the counting of each train as a separate task?
Could you tell me how many brown ones there are? Count out loud, like
1, 2, 3, 4, 5, 6, 7, 8, 9.
okay, if there's 9 brown ones, can you tell me how many blue ones there are?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And how many red ones do you think?
This is back.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
And how many green ones?
1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8.
Brown cubes, do you think there are?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, so how many blue ones do you think there are? You know there's 9 of those. How many blue ones do you think there are?
20.
Should we check and see?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay, now if you know there's 11 blue ones, how many red ones do you think there are?
12.
Why do you think 12?
Because it's bigger.
It's bigger. Are you sure there's 12? How many green ones do you think there are?
That's shorter. 3, 4, 5, 6, 7, 8.
8. How many brown ones?
1,
Yeah, there's one brown train, isn't there? How many cubes did I use to make that brown train? You can count and see.
9,
9. So how many do you think I used to make the blue train?
11,
Okay, and the red train?
12,
Why'd you think that? You said that one so fast. Where did you get that idea?
because this one has 1 more.
I wonder what happened to that little girl when she got older. She was normal after this or not? Yeah.
She doesn't realize that there's a group full of college students watching her. Like, she's an adult now, having her own life.
She might even been in this class. who
I
knows?
wonder if she thinks back to
It
that.
could be me, you guys, that's me up there.
Yeah.
That weird time I teach your video.
Did you see the one girl, how she positioned it to line it up and then she counted them all anyway? What do you notice on there? Anything?
Our little boy is a pretty smart guy.
He is.
Yeah, I think he was the only one out of all of them who ended up counting up, right? Without road counting?
Yeah, I think so.
And you do look at 19.
He got 19. He did really well. That's right, he did get 19 truck.
I think he would have been able to go from the red one to the green one if she had done it kind of in like actual order, like the green then the brown. I think if she'd done it that way, he would have been able to do all of them without the actual counting.
Yeah, so that'd be like a scaffold.
Yeah.
Kayla. I'm sorry.
It's okay. I was just gonna say that he recognizes like what he was doing, like when he was counting backwards, he's like counting backwards, or okay, I'm doing 19.
Yeah, that's right, Carol. I have a Kayla that sits right there. It's either, where does Kayla sit? Does she sit there in the 347, or she sits
She
where?
sit-
Oh, wait a
I think
minute.
she does.
I'm getting everything mixed up.
No,
Okay.
there is,
Caleb,
there's
there's
right
right
here
here.
that sits, like,
Oh, okay.
over in this area, and then I
Yeah.
sit over there, you know. It's okay. One thing I didn't like though is how she kind of hinted at the difference. I felt like, you know, for some students, they'd be able to figure that out just by having that little hint.
Yeah,
So when she said, like, we know there's a lot here, how many must there be here?
yeah, so what she's doing, I mean, that
Like,
wouldn't be a
leading
good,
on to that, yeah.
that wouldn't be a good assessment if you're doing everybody and you're scoring them all. Yeah, that, you have to, that's why they tell you exactly what to say on
Because
those.
I think she asked that for our boy who got to 19, she asked that question, and he said 12, but then he
Yeah.
didn't know where he got 12.
Yeah,
Like, he kind of put it because it's smaller, it's bigger.
because she put in his idea, or an idea in his mind that she did for the others,
Yeah.
that he could use the one. What do you think, though, she might have outsmarted herself, or maybe not even outsmarted herself, she might have done something different to kind of skew the results. Anybody think how she might have made it harder for the kids? Yeah.
Using different colors.
No, that's not what I'm
I don't know, I
thinking.
was just thinking like, if you, like, that's like a way to separate it, so if you see like, I have 3 blue trains and they're different colors, but they're the same color,
Yeah.
they may see it as like more of a unified entity. It's like it's all one thing.
They could.
Whereas like they're saying, okay, she's saying count the blue train, I'm gonna count the blue train.
Yeah.
I don't know.
They could.
Yeah.
That could have some. That wasn't what I was thinking, but
She also probably made it more difficult when she put the 8 in the top instead of doing the 8,
Yeah.
9. Well, they skipped 10 and then they went to 11, 12.
then she went backwards, so how are you gonna go?
So that
And they
might
didn't even go
confuse
back
them.
by 1, they went, they
Yeah.
like skipped.
Yeah, sometimes
That's a
it
pretty
skips
big
by.
jump.
So it wasn't, they probably wouldn't have seen a pattern unless they did 8, 9, 10, 11, and then 12. Then they could have figured out some kind
Yeah.
of pattern.
And maybe if it's almost like she's expecting them to make the connection between the two trains, so she was giving them something harder, and here they weren't making the connections. There's something else. How did she line them up? For us, it was left to right for the viewing. For the students, it was the opposite way. And if you watch the students, they almost always counted from their left to the right, which is what you'd expect. So to see that match, or to make that comparison, they're beginning at something where they can't look at the end and say, oh, they're different. You know, see what I'm saying? They're counting from left to right. She should have turned those around, and she might have got them to see that relationship a little bit better. Just something a little subtle like that.
We saw that Amy still counts all the cubes in each train. Brad, however, is beginning to see relationships, but is not yet always accurate. Linda also is beginning to see relationships and is able to use what she knows about one train to figure out another. In the next assessment, children are asked to respond to the question, how many more?
How many red ones?
4,
How many green ones?
5,
Are there more red ones or more green ones?
green,
How many more green ones?
1 more,
How many green ones?
1,
And how many orange ones?
Seven.
I think there's more green ones or more orange ones.
orange,
How many more orange ones than green ones?
7, 7,
It is typical for young children to have difficulty interpreting this language, so they answer the question as though it were, how many in the group that has more?
How many red ones?
4,
How many green ones?
5,
Are there more red ones or more green ones?
more green ones.
Do you know how many more green ones than red ones? Not sure. Do you think you could find out? If you could break that up or do something with it, do you think you could find out? Or you just don't know?
I'm break it up.
Do you think you could do an experiment to see if there's more red ones or more green ones?
It is not always clear whether the child is having difficulty interpreting the language or in understanding the concept. In order to get more information about the understanding of the concept, I often follow up with another question. How many would you need to make both groups the same?
Do you know how many more green ones?
Uh,
Not sure. What if you wanted the green ones and the red ones to be the same? What would you have to get? Get more red ones or more green ones?
more wagons.
How many more would you need?
What?
How many more red ones would you need to get, do you think?
5,
How many green ones?
5,
And how many orange ones?
7,
Okay. Are there more green ones or more orange ones?
4,
Do you know how many more orange ones?
no. That's all I guess.
Okay. What if you needed to have the same number of green ones as orange ones? What would you have to do? Would you have to get some more, or
Get,
do you know how many more you'd have to get so they'd be the same?
yes.
How many more?
1, 2, 3, 4, 5, 6. I would have to get 2 more.
It is important to remember that we can get valuable in
Okay, so see what it took for to be able to communicate what she was looking for, all those questions. Okay, what do you take away from that? Yes.
I always felt like how many more is a pretty tricky question. Because, like she said, they're trying to explain how many they would need, like, or how many are in the group that has one.
Yeah.
But it's like how many more, and they don't realize that they can have to subtract, because when you take more, you take half.
Yeah, yeah. Oh, I thought something had your hand up.
Oh, well, I was gonna say that, when she had them in a row and was asking them the question, maybe at first they probably didn't think that they could work it up, and they had to like mentally figure out how many there were. And then like she let the one little boy, but he still got it wrong, didn't he? Like,
Yeah, he never did get it.
So,
Yeah, and so, I mean, you bring up two good points, with the, breaking it up. See, she's giving him, she hinted at a problem-solving method to figure out, you know, how many more he would need, okay? And you see that problem-solving method didn't make any sense to him. And I don't know if we talked about it here on 347, but what you're trying to do, like for example, a lot of teachers will say, today we're going to learn how to find the answer to this problem by making a drawing. And so they tell the students to make a drawing, okay? And the students often are like this boy here. They don't understand why they're making a drawing. They don't understand how it's supposed to help them. So they go ahead and they make the drawing. In this case, and he's breaking it apart. You know, it's not his idea. So she's imposing her method of solution onto him. And when you do that, a lot of times most of the students just don't get it. All right? So something like that. So when you're teaching like problem-solving routines, like you know, looking for patterns or whatever, sometimes it just has to come from the students, like to make a drawing. So in this case, if you had several students that were doing this, and one boy ended up breaking them apart, and you say, oh, tell us what you're doing there. You know, in other words, now maybe the others will see that and use that problem-solving strategy. Okay, that's kind of the way like you introduce these problem-solving strategies. Okay, so anyway, so that's one of the things that always hinders us in that when we try and give them a strategy, if it doesn't occur to them, they don't know what to do with it. In other words, tell me, well, okay, I broke it up. Now what do you want me to do? You know, because he doesn't see the end point for that. Okay, and then how many more? We're talking about language issues, communication issues that he's just not used to using the word that way. Okay, that's why he said, I told you 7. You know, so how many more? I told you 7. You know, there's nothing more I can tell you. Okay, so it's simply a language issue. It's not that he doesn't know what to do. Okay, remember we talked about the words like first, second, next, and last. Okay, that more and less are some words we're going to talk about also. More usually students understand because when they're very, very young, that's one of the first words they learn. You know, you want more. But less is not something they understand. Okay, we're going to see that a little bit later.
Through informal observations of them while they're actually working. I am looking for 2 things as I watch John at work. I want to see whether or not he can do the task correctly, but I also want to know how he is doing the task. We can be misled if we only look at children's work after they finish. Too often their right answers can disguise a lack of understanding or a lack of confidence. John can do the work he is assigned, but his lack of ease with the task indicates he needs many more similar experiences. Immature thinking and misconceptions are a natural part of the process of developing number concepts. In order to provide the kinds of experiences young children need, we must be interested in what they are really thinking and understanding, and we must accept and respect the natural stages through which children move. When children's immature thinking is not accepted, they sometimes lose confidence in their own ability to know and understand. Terry and Brad help illustrate this point.
Okay, so how many blue ones are there in the B? 11. So does that help you figure out about the red ones?
Yeah. This is 12.
You sure? Or you just think probably?
Probably it's 12.
I'm gonna check.
I guess 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, now how many green ones?
6.
Okay, and you had a reason for saying 6. I could see something, thinking something. What were you thinking?
That maybe I'll get wrong or right, because he is wrong guessing stuff.
It is clear that Terry does not show much confidence. Contrast the way Brad responds to the questions he is asked.
I don't have
Okay,
red
well,
ones.
well, how many red ones?
4.
And how many green ones?
5. 4, 6, 7.
How many green ones?
5. I can do, because I can see. It's in the red one too.
Well, what if you wanted to make this pile just the same as this pile? Would you need to get some more green ones?
I have a new way to make it forward too.
You do?
Did you notice the confidence Brad shows? He is not always right, but is looking for sense and meaning. He knows when he doesn't know. If he doesn't know what you are talking about, he just changes the subject so he can share something he does know. Children need to see numbers as useful and meaningful tools for making sense of their world. It is important that they be allowed to come to new and more mature understandings in a way that does not interfere with their own sense-making process and their confidence in their ability to think and to understand.
Okay, so the confidence comes into play. She was showing, I think his name was Terry, and he wasn't too confident in his own abilities. And what's her point? Why is she, what is she kind of telling you, the future teachers, that might lead to someone like Terry? What did you say?
Build his confidence.
Build his confidence, okay, yes.
I think it's that whole letting them explore and being able there is like the most important because like she said, I think like one little boy seeing the red like flannel, but he was very confident. She said he didn't always get it right, but he was thinking and she asked questions and like eventually he'll get there because he's exploring with it.
Yeah.
Whereas if like Terry had his set, he was like, oh, I don't know.
Yeah, he gave up easy.
Yeah, he gave up,
Didn't
whereas.
Think about the first math standard, persist.
Yeah.
Okay, persist. He didn't persist too much. Yeah, so that's kind of what you want to build their confidence, and you can hurt their confidence by give them negative feedback for their immature thinking, which she calls immature thinking. In other words, okay, so they did something wrong. Your feedback's really important because she's saying accept whatever they give you as their answer, because that will keep your confidence. Okay, if you accept it, then you're okay. Now Terry, apparently someone wasn't accepting his answers, and so he just developed this idea that he's wrong when he guesses. Okay, or maybe guessing you have to be exactly right. Okay. All right, well that's all we're gonna have for today. So Wednesday, if you show up, we'll have this thing. I'm giving the test Wednesday, so if you come, you know, but if it's too cold and you can't make it, then, you know, just know you have to take the test Wednesday. I don't know if they do it for cold, and I know that we have a lot more computers than we did, you know, like 15, 20 years ago. I have no idea what they're doing. They should, it's below the zero.
I think this is actually a combination.
Yeah. Yeah.
Sorry.
Excuse me.